Hello everyone. In this video, we're going to be denesting a radical, which means we have the square root of 12 plus 11 times the square root of 2, where you can see that we have a radical under another radical, and we're just going to write it as the sum or difference of two radicals. Okay? That's called denesting. So to be able to do that, there's obviously, different ways to approach this problem, and I'm going to try to show you different approaches. But think about another example like this one, 5 plus 2 times the square root of 6. What does that mean? Like, in other words, like, what do you mean by denesting, right? Well, if you can write this as square root of 3 plus the square root of 2, that is denesting, because as you can see, no number is under more than one radical. Does that make sense? And what happens is, if you square the right-hand side, you get what's inside the radical here. So if you square this, you're going to get that. Obviously, that's clear, right? Because if you square this expression, you get square root of 3 squared plus square root of 2 squared plus 2 times AB, and then you're going to get the same thing. But how did I know that it works? Well, this is pretty common, so you probably saw this before. But in this case, things aren't that straightforward. But the idea is the following. If I can go ahead and split this 5 into two pieces such that their product appears here. Of course, you can also do it backwards or maybe forward, who knows. You can factor 6 as long as you have a 2 here. 2 is critical, from the formula, a plus b quantity squared, right? So as long as you have the 2 there, you can factor 6 into 2 and 3, and guess what? Their sum is 5. So now you can write this as 3 plus 2 plus 2 times the square root of 3 times the square root of 2, which basically gives us what we're looking for, right? And of course, that's under the radical, but under the radical, you have square root of 3 plus square root of 2 quantity squared. I know some people don't like the word quantity. I try not to use it, but sometimes it's unavoidable. So here, since the sum is positive from absolute value, we're going to get the result. See, it's pretty quick, but the question is, can we do the same thing here? Well, at least we can try. But the issue is, we don't have a 2. To make matters worse, we have an 11, which is an odd number. So odd, right? But let's try it anyways. Let's go ahead and clean this area, and then start over with this one. So, and the absence of 2 is not a huge problem as long as you can take care of it. Like, you can write this as 2 times 11 halves and put the 11 halves inside the radical by squaring it, multiply by 2, and you'll be good to go. So let's do that first. 12 plus 2 times the square root of, this is going to be, when you square it, it's going to be 121 over 4. And if you multiply by 2, it'll be 121 halves inside the radical. Okay, does that make sense? If you go ahead and square root 121, you'll get an 11, and I guess that should work. Something like that. Did I do that right? Actually, I'm supposed to leave the 2 outside and take 11 halves inside. Okay, I think that should be good. Now, here's what we need to do. We need to split it up into 2 pieces such that their sum is 12, or you can start with 12 and break it down, but product is usually easier. For example, we can think of this as maybe 11 over 4 and 11 over 1 half, which is 22. Okay, that's what it means, right? If you multiply these two things, you're going to get that number. But wait a minute. Is the sum of these two numbers 12? I don't think so, because one of them is a fraction. So that's problematic. And guess what? You're not going to be able to do it this way. But I wanted to show you, it's always worth checking, because in the case of 5 plus 2 root 6 and many other cases, it'll work. This problem is a little bit more challenging, and you'll see what I'm talking about. And by the way, I made a similar problem before. See if you can find it. Maybe if I find it, I'll share the link as well. But this is a pretty interesting problem. So let's see how we can approach it a little differently. So another approach, and if you call this first method, this would be the first. And then the second method, we can go ahead and take the same expression, square root of 12 plus 11 root 2, and try to do it this way. Well, this can be the square of what? This expression I'm talking about, right? It's probably the square of an expression that contains square root of 2 and maybe some other integers. Can it be like this? Square root of 3, a square root of 3 plus b square root of 2? No, because in that case, you're going to get square root of 6 in the middle. You don't want that. So you don't want another radical besides this. In other words, maybe this is the square of a plus b root 2. This is another way to approach it. And I'll show you why this works, again, with our example, and I'll also show you why this works nicely. For example, if you set that equal to this, you would basically square both sides, and then this would give you 5 plus 2 root 6. Oh, by the way, sorry, I got to change the setup a little bit. This is meant to be a root 3 plus b root 2. So that's not a good example, but hopefully you get the idea. Maybe I can pick something that'll work better. Let me think about it. Okay, I think I have another example that'll fit more. Maybe something like square root of, let's think about it. 4 plus 2 root 3. Okay, here we go. This should work. So this can be something like a plus b root 3, right? Because of this. Okay, so the next thing you're going to do is square both sides. And then this should give you, if you square this first, a squared plus 3b squared. Don't forget, you're going to square radical. And then plus 2ab root 3. I want to write the root 3 last, and then that'll equal 4 plus 2 root 3. So what we're supposed to do, just like when two complex numbers are equal, by the way, speaking of complex numbers, I have another channel called A plus BI. Go ahead and check it out. It's all about complex numbers. And let me know what you think. I also have a shorts channel. Once a week, you'll see a video, short or long. Okay, now, in this case, we can safely say that the radical part equals the radical part. So 2ab is supposed to equal 2, and this is equal to 4. That gives us a system of equations, and you can solve it in so many different ways. Again, there's a lot of methods, but ab from here is going to be 1 if you divide by 2. And here, you can isolate b. That's one way to approach it, 1 over a. Go ahead and plug it in. Or, I have a better idea. You can actually square both sides. You get a squared b squared equals 1. And then you can isolate a squared from here, write it as 4 minus 3b squared, and then substitute this. I think that's a better idea. So you can go ahead and take this expression and plug it in here. So you'll get something like b squared multiplied by 4 minus 3b squared equals 1. And if you set b squared equal to c, a lot of substitution by the way, but I like it. And then you'll get a quadratic equation and solve it and then go backwards. Let's try to do it. So if b squared is equal to c, we're going to get 4c minus 3c squared equals 1. And then 3c squared minus 4c plus 1 equals 0. And from here, you probably realize that, okay, c is equal to 1 is going to work. If c is equal to 1, then b squared equals 1, means b is equal to 1 because a and b are supposed to be positive here, and so on and so forth. But if this basically gives you a equals 1, b equals 1, and what happens is this is equal to root 3 plus 1, right? Or 1 plus root 3, whichever, right? That's fairly easy to do though, because we could just break it down into 3 plus 2, right? I mean 3 plus 1. Okay, what happens if we do the same thing here? Let's go ahead and see what happens here. If we go ahead and clean this area up. Okay, cool. Now, we can go ahead and square both sides again, like this and like that. Let's start here. A squared plus 2b squared plus 2ab times square root of 2 equals 12 plus 11 times the square root of 2. So from here we get something similar, a system of equations. This is 12, this is 11. That basically means AB is 11 halves. Like before, remember we did that thing. And then a squared plus b squared, we can square both sides. A squared b squared is going to be 121 over 4. And then a squared plus 2b squared is equal to 12. So from here we can isolate a squared, write it as 12 minus 2b squared, and then plug it in here. Okay, that gives us b squared multiplied by a squared, which is 12 minus 2b squared, 2b or not 2b, sorry, I have to say that real quick. And then set the b squared equal to c, c times 12 minus 2c, or not 2c, that's the problem. And then we're going to go ahead and proceed. 2c squared on the right-hand side minus 12c plus 121 over 4 equals 0. And this equation can be solved with the quadratic formula. But there's a caveat. Let's see. Negative b plus minus the square root of b squared, which is 144, minus 4ac, 4 times 2 times 121 over 4. The 4's cancel out. Cross canceling is amazing. Divide by 2a, which is 4. Now here we have 2 times 121, which is 242. Uh-oh, Houston, we have a problem. I'm getting a negative delta, which means there's no real c values. What is that supposed to mean? This is crazy, right? By the way, you can also approach a solution of the system in a slightly different way, such as you can go ahead and look at the difference between these two things, which is again a technique that's commonly used. If you subtract x plus y squared minus x minus y squared, that's going to give you 4xy. So this should equal 8a squared b squared. Since you know this, you can plug it in, you can find this, and then solve the system that way too. I don't know if it's easier or better, but that's another idea. But notice that this method did not work on this either. Second method didn't work, so what are we going to do? Houston, we have a problem. Okay, we have to use the third method, which is actually what you're supposed to do. But before I do that, let me go ahead and show you why this one denested nicely, right? We didn't have any issues. Why? Here's the reason. If you take this and think about its conjugate, right? What's the conjugate of this number? This one. Multiply those together. Under the radical, you're going to get what? 25 minus 24. Uh-oh, that is the trick. We have a perfect square. So when you square this number and square that number and subtract them, if the difference, kind of like a norm sort of thing, then if you get a perfect square, then things are good. So why not do the same check with our radical? What's our radical? The square root of 12 plus 11 root 2, right? Let's do the same thing. Take this number, square it. Take this number, square it, and then look at their difference. This is 144. This is 121 times 2, and that is 242. This is 144. Uh-oh, Houston, we have a problem. Their difference is problematic. Okay, fine. Then maybe we can switch them around and look at the difference this way, right? Then it'll be a positive difference. Okay, let's still, problem is, it's going to be 98, which is not a perfect square. But it is 2 times a perfect square. Aha, that's the trick, because it's 2 times 49. What is that supposed to mean? I'll show you. We do need to extract something out of it to make it better. So here's what we need to do. And this is actually the whole solution. This is how the problem was designed. But why didn't you show us this in 30 seconds? Then we wouldn't be able to hit the YouTube algorithm, right? And plus, I want to show you alternative methods, wrong approaches, right approaches altogether. This is not about 30 seconds. Come on. This is not like a Instagram reel or a TikTok or something like that. This is serious stuff. YouTube, right? YouTube math. Okay. Now, here's what we're going to do then. We're going to need to take care of this so that take out some 2 maybe, but remember, we're squaring it. So something squared equals 2 means we need to take out a square root of 2. What is that supposed to mean? It just means that can you factor out a square root of 2 here? And the answer is yes, because 12 is 6 times 2, and 2 is root 2 times root 2. So when you factor out square root of 2, you'll take one of these, but you'll still have this, plus 11. Interesting. Let's switch these numbers around, and let's write it this way. And the reason why I want to write it that way is I always want my radicals to look like this, a plus b root c, where c is not a perfect square, a and b and c are all positive integers, but c is square free. Make sense? Okay, now, what do? We check the difference of squares again. Square this number 121, square this number 36 times 2, which is 72. We look at the difference and we get 49. That does the trick. So, but what are we supposed to do though? Here's what you need to do. Split this up into a product, okay, like this, okay, and then this one should resolve nicely. How? Again, you have 2 methods. You can go ahead and set this part equal to a plus b root 2, or you can do it the short way, which is, you need a 2 here. So let's go ahead and get rid of the 3. I can just go ahead and put it inside. 3 squared is 9. 2 times 9 is 18, so it's going to turn into this, which is easily denestable, but this is the square root of 2, by the way. You got to be careful there. Now, what are we looking for? We're looking for 2 numbers whose product is 18, and whose sum is 11. And those numbers are 9 and 2, because 9 times 2 is 18, 9 plus 2 is 11. There you go. So now you can go ahead and write this as square root of 2 times square root of 9 plus square root of 2, which is 3 plus the square root of 2. But what about this? What kind of radical is that? Is that denested? Yes, because the square root of 2 means it's just the 4th root of 2 in this guy's, right? And this is 3 plus root 2. Well, you're not done until you simplify this as much as possible. Let's do it. What are we supposed to do? Distribute. When we distribute, we're going to get 3 times the 4th root of 2 plus these two numbers. You can't multiply them, right? Well, you can kind of write it like this, 2 to the power 1/4 and 2 to the power 1/2. And then this is 2/4, 3/4. You can do that. But that means it's the 4th root of 8, right? So it's going to be 4th root of 8. And guess what? This is going to be in the denested form. Basically, that is the final answer. And this brings us to the end of this video. Thanks for watching. If you enjoyed it, please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out SyberMath, which is this channel, the Shorts channel, and aplusbi, and bye-bye.